This theorem is this really long, on the first page, bottom page 329, by the way, is where we are. We have this really long definition of this theorem. It says, if P over Q is in simplest form and is a rational root of the polynomial equation, and they give this long polynomial equation with integer coefficients, then P must be a factor of a sub naught and Q must be a factor of a sub n. So many words, right? So many words. I'm pretty sure. What does this mean? All right. This means that if you have a root of this, what do I mean by that? A zero. Like if you have a number that when you plug it in, you're going to get it equal to 0. Okay. Then it has to come from the factors of your leading coefficient, the very first guy that's in front of your first here, and the constant. So let's say my leading coefficient is a 2. Like say we have 2x cubed and we have dot, 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 all that in between. That's what all that is. And then we have a 5 at the end. Okay? What they're saying is that your 0 for that polynomial is going to come from the factors of this 5 over the factors of that 2. Well, what are the factors of 5? Well, 1 and 5. Those are the only factors of 5. What are my factors of 2? Well, 1 and 2. That's pretty straightforward, right? So that means that my zeros have to be 1 over 1, 1 over 2, 5 over 1, 5 over 2. And they can be the positive and negatives of those. So it could be the positive and negatives of all of these. So my zeros could be positive and negative 1, positive and negative 1/2, positive and negative 5, positive and negative 5/2. So that's what they're telling me, that if I'm going to have a 0 for this polynomial, it will come from the constant and the leading coefficient, their factors. That's how it works out. Weird that it works out that way, but that's how it works out. It works out that way likely because when you start, like think about trinomial, think about something that you can get your brain around. Really, for a trinomial, you use the factors of the last guy and the factors of the first guy to come up with what you factor it to be, correct? And so it makes sense that then what's going to make it 0 would then come from those factors, right? And so it also works for large polynomials, not just quadratics that we've dealt with, okay? And so that's all this huge theorem is saying. So we're going to look at that and we're going to do a couple of these. I will say that when I ask for this information, hey, list all the possible numbers that could be a 0, and it could be this huge long list. And then it'll say, find the zeros. I never make you go through that list because it could be like 20 different times that you could have to check it. I always typically hand you a 0 and say, okay, here's one of them. Now find the rest of them using synthetic. So as we go through this process, the book itself has you plug in like 3 or 4 of them. I always actually hand you one so that you don't have to spend 45 minutes trying to find your first one. Okay? So let's look at the first example. Find the rational roots of x cubed plus x squared minus 3x minus 3 equals 0. So the first step here, it says, is to list the possible roots. What is possible for this to have as a root? Well, I'm going to look at my last term, my constant, and I'm going to look at my leading coefficient, which in this case is a 1. All right. So all of my possible roots will come from those two numbers. Well, the only factors of 3 are 1 and 3, right? So my factors of 3 are 1 and 3. If my leading coefficient is 1, that is my only option here, right? So this numerator will come from the factors of this last guy. The denominator will come from the factors of the first guy, okay? And I have to consider the positive and the negative because I could have -1 times -3 or -1 times -1, right? So, I mean, I could have positive and negative that can make that up. So my options are positive and -1 or positive and -3. So if it says list all possible roots, possible rational roots, that's what it wants. It wants everything that it could possibly be. So that answers that question. List all the possible rational roots here. Then it says find them. Now, if I just have 4, that's pretty easy. I can test 1, I can test 3, right? By testing it, you could plug it in, right? I could plug it in and say, does this give me a 0? What's another way I can figure out if it's actually a 0? besides just plugging it in? You just did it on your quiz. What's another way to test if positive 1 is a 0 of this, or if negative 3 is a 0? Synthetic substitution, right? Synthetic, which is synthetic division, right? So I could either plug these numbers in and say, do I get 0? Or I could do synthetic division. I could say, well, do I get a 0 when I plug it in? And so in the book, it starts with 1, and then it goes to negative 1, and then it goes to, 3 and negative 3 to see if you get a 0, all right? And so if you start with 1, you would just do your synthetic division. I have a 1, a negative 3, a negative 3, and I would just do my multiplication, my addition, right? 1 is not a 0. And basically what you would have to do is you would have to go through all of those and see which one works, okay? If any of them work, for that matter, actually. You'll see, if you look in your book, you'll see that negative 1 actually works. So if I do this process with negative 1, you're going to see that this is actually going to work. 1, negative 1, 0, negative 3, positive 3, 0. So this guy is actually a root. So negative 1 is a root, and it comes from one of my possible roots. That's how it should always work, if there are any rational roots together, because we're not going to do the synthetic division here. If I were to look at this guy, 1x cubed minus 4x squared minus 2x plus 8, what would be my possible rational roots? Well, I have to look at my factors of 8. What are my factors of 8? 1 is a factor, right? And that's how I do it. I pair it up. Yeah, 1 and 8, and 2 and 4. Those are all my possible factors, right? Since my leading coefficient is 1, those would all be over 1, so that doesn't change anything. But I do have to consider the positive and negative here. All right? So that 8 possibilities for a rational root here. 8 possibilities for a rational root here. And by the way, the one that works is 4. This is why I give it to you, because some of you would go 1, negative 1, 2, negative 2, 4, and you wouldn't get it until you'd done it 5 times. Okay? But 4 is actually a root here. It's the only rational root you get. So that means the other 2 roots are either irrational, square root, or imaginary. Okay? Find the roots. 2x cubed minus x squared plus 2x minus 1. Okay? So in this case, my constant is a 1. That's easy. Positive and negative 1 are my only options there. My leading coefficient is a 2, so I have 1 and 2. So that means my possible roots, well, it's going to be 1 over 1, which is just 1, but I do need my positive and negative. Or it could be 1 over 2, right? Positive and negative. My factors of 1 are 1. My factors of 2 are 1 and 2. So those are my possible ones here that I get, all right? In this case, you'll see in the book, if you test positive 1, you get a remainder. So if you were to do synthetic division with positive 1, you're going to get a remainder of 2. So positive 1 is not going to be it, all right? They actually tell us that 1/2 is the root, all right? They tell us that 1/2 is the root, and I'm going to actually do this with a 1/2. I know y'all probably don't like doing this with a 1/2, but that's okay. We have 2, negative 1, 2, negative 1. All right, so 2 plus 0 is 2. 1/2 times 2 is 1. We get a 0 here. We get 2 here. All right, so they were nice. It always works out beautifully when that happens, all right? So we know that if it says list all the roots, then we know that my actual root here is going to be 1/2, but I want all of them. So let's look at what they've given us here. We now have this guy. So I'm going to put this back into polynomial form because it'll be easier to see. I started with x cubed, so I'm going to change that and make it 2x squared. All right? That would be plus 0x, which I don't need to write, and then plus 2. All right? So I have this polynomial. How would I find my remaining roots? What do I need to do with him? I need to find what makes this 0. So I need to say, well, let's set it equal to 0 and see what happens, okay? Yeah, you can factor, or just subtract your 2 over, right, if you want to. Subtract your 2. we're going to get 2x squared equals negative 2. Divide by 2, x squared equals negative 1. Take the square root. What is the square root of negative 1? I. And because it is, we're going to say positive or negative I. So my other roots are positive and negative I, correct? So I have a root of 1/2 and a root of positive and negative I. Okay? So if I were to give you a question like this, I would say list all the possible rational roots. That would be this answer right here. Then I would say, okay, 1/2 is a root. Find the rest of them. You would need to divide, synthetic division, and then you would need to factor, or potentially, if you can't factor, solve by quadratic formula. Okay? So if you can't factor or solve that way, you need to solve by quadratic formula. And so you would first say, okay, list the roots, use synthetic. So we would divide. By the way, if you divide by something I told you was a root and you do not get 0 as a remainder, you divided wrong. So you need to go back and check your division, okay? So divide, and then you're going to do whatever method you need to, potentially factor, maybe quadratic formula, all right, depending on what works for that particular quadratic that you have left over. All right, so if I were going to list all of these, my factors of 10 are going to be 1, 2, 5, and 10, right? Those are all over my factors of 1, which is just 1, and then I have to consider the positive and negatives there. So this is what it would look like if you listed all possible. So this is all possible. That's what that question is going to look like. List all possible rational roots, okay? And then I handed you one. I said positive 2 is a rational root. So then your next step is to determine what you have left over after you have used your root of 2. And so I would use synthetic division here. You could use long division if you want to. Okay, but all right, we have 1, negative 2, negative 5, positive 10. And then we're just going to use division here. All right, and you can see that you have that there. Easy enough. All right. Then I'm going to take that, so I'm going to start with x squared plus 0x minus 5 equals 0, because this guy's easy. I'm just going to set him equal to 0. Add my 5. X squared equals 5. So x is going to equal the positive and negative root of 5. So then I just want to point out, I have given you a root, and I wanted you to find all of them. So you're going to have a couple answers, and we're going to build these answers as we go. This is one of your answers. These are all possible roots, okay? Then if I said list all the roots, I would want you to say my roots here, so my zeros or my roots, however you want to list it, list the one I gave you. Okay, don't forget about the one I gave you because that is a 0, and positive and negative square root of 5. And so then that would be the other piece of your answer there. The reason I'm saying list the one I gave you is because I should be able to take your zeros and put them into binomial form and go back and get that polynomial, okay? So if you forget to list the one I gave you, you're not going to get the original polynomial, okay? So list the one I gave you and then any other ones you found. For this one, your factors of 1, well, that's easy. It's just 1. So you could put 1 over, my factors of 3 are 1 over 1, or my factors of 1 over 3. Factors of 3 are 1 and 3. So 1 and 3. Positive and negative. So this is going to be my all possible here. These are all possible. That's the first part of this answer. Okay. And then I want to find them. And I gave you negative 1 as a root. So I'm going to say, well, negative 1 I know should be a root. So I'm going to say 3, 1, negative 1, 1. And I'm going to do this here. That's negative. Positive 2, 1, negative 1, 0. All right. I'm going to get that. I'm going to put that into quadratic form. So I have 3x squared minus 2x plus 1 equals 0. This guy's not factorable, okay? So what's my other option since I can't factor it? Quadratic formula. So you should have done quadratic formula here. Negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. You're going to get an imaginary number here, hopefully. We have 4 minus 12 over 6 You can factor that out, by the way. This is going to be -8. So it's just 2i squared root of 2, hopefully. All right, so we have 2 plus 2i squared root of 2 over 6. My 2, and my 6 reduced to 1, 1, and 3. So if I were to list my zeros here, I would get the one I gave you, -1. And then I would get 1 plus or minus I squared root of 2 over 3. Or you could have said 1/3 plus or minus I squared root of 2 over 3 if you wanted to split that guy up. But those are your zeros. Let a and b be rational numbers, and let square root of b be an irrational number. If a plus the square root of b is a root of a polynomial equation with rational coefficients, then the conjugate a minus the square root of b is also a root. Okay, what this is telling you is that irrational roots come in pairs. That's what they're saying, okay? Why is that? Well, look at the example we just did, 2a, all right? I had x squared equals 5. Why does it come in pairs? Because I have to consider the positive and the negative root, okay? And so if I have a square root of 5, then I have to have a negative square root of 5 that goes along with him because he was generated from x squared equals 5, okay? So anytime you have an irrational root, meaning a square root that does not simplify, square root of 5, you will have its conjugate, you will have its little partner in there, okay? So if I have square root of 5, I'm going to have negative square root of 5. If I have 1 plus the square root of 5, I am going to have 1 minus the square root of 5. They will always come in pairs, okay? Which the next page that we're about to do says the same thing about imaginary numbers. Why? Because imaginary numbers stem from the square root of -1, which means, again, I have to consider the positive square root of -1 and the negative square root of -1. So both irrational and imaginary roots always come in pairs. So on your quiz, if I said, hey, you have a 0 at 1 and a 0 at square root of 5, find the polynomial. You would need to assume that you also have a square root of negative square root of 5. Okay, that you have a root at negative. Okay, so even if you're not told that, you need to assume that you have a partner that goes with it. Okay, meaning that your degree will not be just 2, because I only gave you 2 zeros. Your degree would actually be 3, because you would have an extra one in there because that root has a partner. Okay, does that make sense? So all of this verbiage here is just saying, hey, if you have an irrational root or an irrational 0, he will have a partner that goes with him that is his conjugate. Okay, this is all this theorem is saying. So a polynomial equation with integer coefficients has the roots 1 plus square root of 3 and negative square root of 11. Find 2 additional roots. Well, I just need the conjugates of those. So I'm going to take this guy here. He is going to generate an additional root at 1 minus the square root of 3. All right. And then I am going to do the same thing here. The negative square root of 11, well, he will also have a root that partners with him at the positive square root of 11. Simple enough. That's all this is saying. That rational roots partner up. Positive and negatives, okay? You will have the conjugate. The reason I use the word conjugate is that if it's in the binomial form, right, where I have 2 terms, then you have a plus and minus. Remember a plus b, a minus b, they pair up, okay? That's all this is saying, all right? And this will matter when we start using them to find the polynomial in the next page, all right? So let's look at the imaginary roots, page 332. Imaginary number, a plus bi is a root. Then the conjugate a minus bi is also a root. Complex conjugates, that just means conjugates with imaginary numbers in them, okay? That's all that means. This is saying the same thing. If you have an imaginary root, it will also have a conjugate that is also a root, okay? For the same reasons. A polynomial equation with integer coefficients has the roots 3 minus I and 2i. Find 2 additional roots. Okay, I'm going to do the same thing I just did on that prior example. 3 minus I, that's going to give me 3 plus I, also as a root. Positive 2i, that's going to give me negative 2i. So I will have 4 roots here. All right, I will have 3 minus I, 2i, 3 plus I, negative 2i. So my degree for this polynomial, if I were to find it, would be 4. My degree here would be 4 because I have 1, 2, 3, 4 roots. So this tells you automatically, now I'm not going to say third degree, I'm just going to say find the polynomial. All right, with rational coefficients, that has roots 3. So they gave me a root of 3 and 1 plus I. All right, I have 1 plus I. I need to assume I have one more root, even if they didn't say third degree polynomial. What's my third root here? 1 minus I. There we go. Okay. So that means I need to set up 3 binomials. So think back to what we did prior to this section. If I said you have a root at 1, 2, and 3, you would say, oh, x minus 1, x minus 2, and x minus 3, right? That's how you would set those up. X minus whatever root I just gave you, okay? We're going to do the same thing here. All right, so I have x minus 3. That's this guy, okay? I have x minus 1 plus I. That's that guy, okay? And I have x minus 1 minus I. That's that guy. And it wants me to find the polynomial. So in the process, it's going to be hideous, okay? And then it's going to simplify, all right? So just trust me. I will say, anytime you have conjugates, those are the ones that you want to multiply together first. Conjugates, always multiply the conjugates first. Do not distribute that x minus 3 through. That would be annoying. Do the conjugate piece first, even though it's hideous, all right? So let's do the conjugate piece. We're going to just FOIL x times x. So we're going to leave this little x minus 3 out here to its own little process. X minus x, or x times x is x squared. X times this group. Don't distribute it through right now, okay? So we have a positive x, and the negative here is going to be a minus, and I have an x times this group, 1 minus I, okay? So far, so good. Now I'm going to distribute this group. I have a negative group times x, so that's going to be a negative x 1 plus I, okay? So far, so good. Now I have negative times a negative, so this guy's going to be plus, but I have conjugates here. So I have this 1 plus I and this 1 minus I, okay? Everybody see that? So far, so good. Now we're going to simplify those brackets is what we're going to do. So we're going to leave this x minus 3 out here by herself. All right, we're going to leave this guy alone, x squared, okay? Distribute this negative x. Ready? So negative x times 1, negative x times negative I is positive xi. Good? Distribute this negative x. Negative x times 1, that's negative x. Negative x times positive I is negative xi. We good? Now this last piece is conjugates. So I'm going to do a little side note over here. I have a plus b, a minus b. What does that FOIL to? It's a special case. What's it FOIL to? A squared minus b squared. The first guy squared minus the second guy squared. That's how conjugates always FOIL, okay? I have conjugates here, okay? Right? So it's going to be the first guy squared. So this is going to be the first guy squared, 1 squared, minus the second guy squared, I squared. Right? Everybody see that? All right. Now let's simplify this piece of it. All right, we're going to leave this x minus 3 alone. Let's do that in a different color. So x minus 3. X squared can't simplify, right? He's all by himself. We have a negative x and a negative x. What's negative x minus x? Negative 2x. All right. We have a positive xi and a negative xi. What happens there? They cancel. What is I squared? So we have 1 minus a negative 1. What's 1 minus a negative 1? That's 2.
Oh, wait. Yeah, it's 2. I was like,
2.
wait, what?
All right, see how pretty that works out? It's always going to work out nice and pretty. Your eyes are going to go away. They're going to go away because we got the I from a regular polynomial, okay? It told us that we had real numbers for our polynomial. Now we just have to distribute your x minus 3 and we're done. So we have x all the way through here, okay? So we end up with x cubed minus 2x squared plus 2x. Then we're going to distribute our negative 3. We have negative 3x squared plus 6x minus 6. And then we've just got to simplify him. X cubed simplifies, right, by himself there. We have negative 2x squared and negative 3x squared. We have positive 2x, positive 6x, and we have negative 6. That is my equation here that I was looking for.
The first x, isn't that one supposed to be a 3? Like where it says x squared and then